Welcome back from the ad break, and let's continue with our lesson. So we were still working with that pre-knowledge practice. Let's continue. So now we are going to work with some calculations. It says they calculate the following without the use of a calculator. We have been given there 2 exponent 5 divided by 8 plus 3 exponent 1. Now for us to calculate this, we need to calculate that power individually first. So we are going to look at that 2 exponent 5. Let's do our calculation here on the side. So when we are looking at 2 exponent 5, I hope you can remember from our previous example, but we did say it is a 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by another 2. Now 2 multiplied by 2 will give us a 4, and we are going to multiply that by 2 multiplied by 2 multiplied by 2. Then we have the 4 multiplied by 2, that will give us an 8 multiplied by 2 multiplied by 2. We have 8 multiplied by 2, which gives us a 16 multiplied by 2. And finally, we have 16 multiplied by 2, which gives us a 32. So we can see there that our 2 exponent 5 will give us there a 32. We are still going to divide that by 8, and we are going to add our 3 exponent 1. That just means that our 3 base 3 is written there once. Now remember, when we are working with multiple operations, we work on either sides of the addition or the subtraction. Now this means that we are going to first calculate the 32 divided by 8, because as we can see there, we have our addition, which means that that 3 is going to be calculated alone. So from here then, we have our 32 divided by 8. So that means that we are going to now calculate that 32 divided by 8. Remember, we are going to start with that 32 divided by 8 because we are working on either sides of the plus or minus. So since as well we have a plus there, we are going to start with what appears on one side of that plus. That is that 32 divided by 8. So what is 32 divided by 8? Or how many 8s do we find in 32? If you are thinking of 4, then you are absolutely correct. And then we are going to say that plus 3. And of course, as we know it, 4 plus 3 is going to give us a 7. And that is our answer for that calculation. Let's move on to the next one there. So there we have our 8 exponent 2 minus our 2 exponent 2 multiplied by our 3 exponent 2. Remember, we are working on either sides of a plus or a minus, which means that we are going to calculate that 8 exponent 2, and then we are also going to calculate that 2 exponent 2 multiplied by the 3 exponent 2 together, because it is on either sides of that minus. So what is 8 exponent 2? That is our 8 multiplied by 8, and we know that 8 multiplied by 8 is 64. And then we are going to calculate that 2 exponent 2, that's 2 times 2, giving us a 4. We are going to multiply that with our 3 exponent 2, that's a 3 times 3, and that is going to give us a 9. Now, remember, we still need to calculate that 4 multiplied by 9, and that is going to be, so we have our 64 minus, what is 4 multiplied by 9? If you are thinking of a 36, then you are absolutely correct, because 4 multiplied by 9 is 36. Now, finally, we are going to calculate 64 minus our 36, and that is going to give us a 28. Did you also get 28? I know you did. So that was our pre-knowledge questions. Let's move on now to the keywords that we are going to be using during this lesson. So we are going to look there at power, which is a base raised to the exponent. So for example, we have a base 2 and an exponent of 5. That is a power. Then we have a base, which is the number that is being multiplied. So for example, with again our power of 2 exponent 5, then the 2 is the base. And then we have exponent, which is how many times the base is being multiplied. So for example, 2 exponent 5, then there the 5 is the exponent. Let's go over now to the first concept in our concept map, and that is comparing and representing integers in exponential form. So we are going to start with comparing integers in exponential form. Now, before we can compare integers in exponential form, we first have to expand the exponential form, and then we can compare the two integers. Let's look at how we can do this. So now when we have a 3 exponent 4 and a 4 exponent 3, before we can compare these two integers, because we really cannot tell which one is bigger or which one is smaller, so we need to first now expand them to exponential form before we can compare them. Now looking at that 3 exponent 4, we know that is 3 multiplied by 3 multiplied by 3, and we multiply that by 3. And we also know that on this side, the 4 exponent 3, that is going to be our 4 multiplied by 4 multiplied by 4. So what is the result going to be from these ones? Now we know that 3 multiplied by 3, that is going to give us a 9. And we are going to multiply that by 3, that is going to give us a 27. And what is now 27 multiplied by 3? If you are thinking of 81, then you are absolutely correct. What about on our right hand side? Now we have 4 multiplied by 4. Now 4 multiplied by 4, that gives us a 16. Now do you know what is 16 multiplied by 4? If you are thinking of our 64, then you are absolutely correct. So this now then means that 3 exponent 4 is 81 and 4 exponent 3 is 64. Now doesn't that make it easier for us to compare those two numbers? Now which one is bigger and which one is smaller? Yes, you are correct. The 81 is bigger than the 64, and that is us comparing those exponents or those powers. So before we compare them, we need to expand them. So let's put this in practical use. Let's look at the next example or the next question. It says there, compare the following integers by filling in the inequalities or an equal. So let's look at the first one there. It has 7 exponent 3. And then we are supposed to compare it with 8 exponent 2. Now let's start off with the 7 exponent 3. This is 7 multiplied by 7 multiplied by 7. And we are going to compare this with a 8 multiplied by an 8. So 7 multiplied by 7 we know is 49. But what is 49 multiplied by 7? Now remember, this brings us back to those square numbers and those cube numbers. And I believe you know that 7 exponent 3 is going to give us 343. And we need to now compare that with, we are going to compare it with 8 exponent 2, which is 8 times 8. And that, of course, you should know is 64. Now, which one is smaller and which one is bigger? Yes, if you are thinking that 343 is the bigger one, then you are absolutely correct. That means there that 7 exponent 3 is bigger than 8 exponent 2. Let's look at the next one there. We have been given there a negative 9 exponent 1. And we are going to compare that with a 3 exponent 2. Now, a negative 9 exponent 1 is negative 9. And we need to compare that with a 3 times 3. So, negative 9 being compared with our 3 times 3, which is a 9. Now, which one would you say it is? Is the negative 9 bigger? Is the negative 9 smaller? Or is the negative 9 equals to the 9? Well, if you are thinking that the negative 9 is smaller than the positive 9, then you are absolutely correct. They might look equal, but because one is a negative number and the other one is a positive number, that means that the negative number is the smaller number. So the negative 9 exponent 1 is smaller to our 3 exponent 2. Let's move on to the next concept in our concept map, and that is the first law, which is a multiplication of powers of the same base. So now if we have 5 exponent 2 multiplied by 5 exponent 5, now before we can calculate these, we need to expand them, and of course we know how to do that. So we are going to expand 5 exponent 2 and we are going to expand 5 exponent 5. Now, how do we expand 5 exponent 2? That is going to be our 5 multiplied by our 5. And what about our 5 exponent 5? That is going to be 5 times 5 times 5 times 5 times 5, because here 5 is multiplied by itself 4 times. Now, what is our answer going to be here? How many 5s do we have in total? If you are counting 7, then you are absolutely correct. That is why our answer is going to be 5 exponent 7. Now, look at that answer that we got. So we got 5 exponent 7 from multiplying 5 exponent 2 and 5 exponent 5. Where do you think that 7 comes from? Well, if you are thinking that we took the exponents and said 2 plus 5, then you are absolutely correct, because they will give us a 7. Let's see if this is true with other multiplications of powers of the same base. Now, this time we are going to use variables where we have a exponent 3 multiplied by our a. Now, we know that we are going to expand these powers, but do you remember what is the exponent there on this a? Well, if you are thinking that the exponent is a 1, then you are absolutely correct. Remember, if you do not see an exponent there, there is always an exponent, and that is our exponent 1. It is not 0, it is 1. So now we are going to expand these powers individually. Now a exponent 3 is a multiplied by a multiplied by a. And we are going to multiply this by a exponent 1, which is of course just the a. Now, do we know what our answer is going to be from here? Yes, if you are thinking that the answer is a exponent 4, then you are correct. That is because we have 1, 2, 3, and 4 a's. We have a multiplying itself 3 times by itself. So that gives us a exponent 4. But can you see where that 4 comes from? Well, if a exponent 3 multiplied by a is a exponent 4, of course, we took the exponents and we added them. So that is 3 plus 1, and that gives us 4. So the same thing applied to our first example, and now it is applying again. What can we summarize from this? Now, in summary, we can now say that if I am multiplying powers of the same base, so we have a base A and a base A, what is going to happen to the exponents if I am multiplying these two powers? Yes, we are going to add these exponents just like we did in the previous examples. Let's look at 1 or 2 examples. So again, just as a reminder, in summary, if I have the same base, then I am going to add the exponents, and this is only if I am multiplying powers of the same base. Let's look at this first one here. It says they simplify the following. So we have 2 powers there that are being multiplied, and when we look at the 2 powers, they have the same base, which is a base 2. So what is going to happen to our exponents? Well, according to what we have done just now previously, we are going to keep that base there and we are going to add those exponents. So our answer is going to be a base 2 and an exponent 8. Let's look at another example. Now we have a negative 7 exponent 4 being multiplied by a negative 7 exponent 3. Now, do they have the same base? Yes, they do, and that base is a negative 7. And what about them being multiplied? Of course, when we are multiplying powers that have the same base, then we know that we are going to add those exponents. So that is going to be our 4 plus our 3, and in the end, that's going to give us a negative 7 as a base and a 7 as an exponent, and that is our final answer there. Let's quickly go to an ad break, and then we will continue with our exponent laws.